Welcome to topic 2 of module 4. In this topic, we will be trying to relate the machine learning concepts and the network security, like how we will perform machine learning on different aspects of the network security components. So, the four most important component or concept of machine learning is pattern mining, which is primary strength of machine learning. We identify inherent patterns in the network traffic data. So, for example, we inspect the three-way handshake, which is the start of any TCP connection. So, this is one pattern that we are looking into the network. Now, network traffic is strictly governed by a set of protocols. So, any deviation can actually give us an anomaly, which results in structures and patterns in the data. So, what we do is that we also try to find malicious activity in the network, especially by mining the pattern and drawing correlations in the data. So we go for attack detections and those attacks that rely on volume or iteration, such as network scanning or denial of service attacks. Now, automatic feature learning is one method of drawing conclusions from the data. So we can have, for example, unsupervised feature learning and deep learning algorithm which do not require any manual or substantial effort on feature engineering and selection. So we give the data to the deep learning algorithm like LSTM, like CNN, and they do the feature extraction itself. Now, there is a difference between unsupervised feature learning from unsupervised learning. The former refers to the automatically generation of features from the raw data, whereas the latter refers to the machine learning unlabeled data. That is, we perform the machine learning using unlabeled data. This is called unsupervised learning. And when we have unsupervised feature learning, which is mostly used in the deep learning algorithms, where we don't provide any features and the deep learning algorithm automatically performs the feature extraction itself. At the transport layer of the network security, we have the two protocols or two main features, data integrity and the privacy. So TLS encapsulation actually try to prevent the unauthorized packet sniffer in the network to obtain only encrypted packets, or the packets don't reveal the useful information. From the machine learning perspective, we extract the information from the TLS encrypted traffic, which is an extra step which is needed to decrypt the traffic, decrypt the packets as well. So any SSL or TLS encrypted traffic has to be decrypted in order to extract the useful features for machine learning. There are various packet analyzers which are available, and they try to inspect or sniff the packet or network protocols which are running on the network. They intercept and they log the traffic in the network. So these logs are useful for security investigations, for debugging any error, for performance studies, and for operational monitoring. And it is a valuable tool for generating detailed data sets. When situated in the right places in the network, these protocol analyzers are actually our primary tools for generating the data sets that will be used in machine learning. Now, there are a variety of tools which are available for packet analysis. So, chief among them, the command line tool TCP dump, which is a powerful tool that allows to capture, parse, filter, decrypt, or search through the network packets, but it is not able to perform any decryption of the SSL TLS packets. Another tool is Wireshark, which is an alternative to TCP dump and has some additional features as well. If you provide the key, so Wireshark is also able to convert all the encrypted traffic with the help of the private key which is provided. Then we also have the SSL dump, which decrypt the SSL and TLS packets provided the key is available by the administrator. Now, feature generation from the network traffic is one of the most important steps for performing any pattern mining or anomaly detection. So we need to have access to the information rich raw data. The next step will be to generate the useful features for data analysis. So you can see from the figure that we have a dummy attacker's TCP session that is trying to remotely perform an exploit of a system. The basic information that we extracted from this communication is the session duration, which is this much. The total session packets are 10. Protocol that was used was TCP. The total number of bytes from source to destination and the total number of bytes from destination to source, the successful TCP handshake status, and the network service on the destination was HTTP, and the number of acknowledged packets are 4. So this way we are going to extract useful features by accumulating multiple information from the packets or from the set of packets, and this way we will be actually generating our features for upcoming processing through machine learning. We can also have application specific feature extraction as well. So for example, while aggregating patterns across large sequences of packets can allow us to generate more useful information than analyzing single packets. However, for example, if we are detecting SQL injection over the network by doing analysis at the packet level, this will cause us a lot of overhead because we have to do a lot of packet analysis if we are trying to detect the SQL injection. On the other hand, the internet control message protocol, that is the ICMP flooding, if we are detecting the ICMP flooding DOS attacks, we require analysis of the packet because there are no sessions to speak of. Like we have the sessions in the SQL injection case, we don't have any session in the ICMP, so we have to perform analysis of all the raw packets and there are no sessions in that. Application specific feature extraction, so we can look at the telnet protocol. There is no encryption in telnet, whereas in the SSH, which replaces the telnet, there is a strong encryption that is going on and which prevent the interhost communication from being snooped or hijacked. So features that we extract from this type of application specific feature extraction is application protocol, whether it is encrypted or not, whether the failed login attempt was made or the successful login attempt, root access was attempted or not, or this is a guest login, what is the URL or wget command that is executed. So all of these will be useful in doing any pattern mining or anomaly detection.